So we're going to start the podcast.
All right.
For people, and it's Zach who's in charge here.
All right. Hello, and welcome to episode number 40 of the Mostly Erlang podcast. And yes, if you've been following the feed, you'll notice that there's a missing one in there. It's because episode 39 has been recorded but not edited yet. It takes me, there's a certain log time there. So, but welcome to Mostly Erlang Live. Thank you everybody for coming. If you have questions, Robert will have a microphone, or you can tweet them, hashtag Mostly Erlang Live, and we'll catch them up here. Because the most efficient way to get information from you over there to us up here is via Twitter server in California. All right, so we have a panel. We're going with Kostas. Why don't you start and just go down the line and everybody introduce yourself.
So I'm Kostis Agonas. I'm involved in Erlang for the last 15 years in Uppsala University, mostly, leading the Hype team. And then doing a lot of changes, also at the runtime system, but also building tools around Erlang.
I'm Erik Stenman, and I've been doing Erlang since 94, 95, and wrote the first native code compiler for Erlang. And now I have a microphone. I've been doing Erlang since then, working with Klarna, and now I'm working for my own company, Happy Hacking, and writing a book about the Erlang virtual machine.
Cool. Okay, I'm Patrick Nyblom. I'm a former member of the OTP team. So I've worked with a virtual machine for like 16 years, and now I've jumped ship, so I work at Google.
You what?
Work at Google. For Google.
My name is Lucas Larsson. I work currently at the Erlang Solutions. I've been a consultant at the OTP team doing virtual machine stuff for 4 years now, 5 years, something like this. So,
all right. So our goal today is to talk about the Erlang virtual machine, and so let's start with. What is just sort of the basics of what is a virtual machine and why would we want one? Some people don't know any, so for somebody who's never heard the words virtual machine before, what is it and why is it a good thing or a bad thing?
well, you want a virtual machine in order to have the same software run on different hardware without having to recompile it, for instance. So having the same characteristics in order to make your system run on Windows, Linux, PowerPC, x86, etc. on the same thing. Then you build a virtual machine that abstracts away the different hardware and operating systems and runs in the same way on the different.
So I'm assuming everybody here, of course, knows what a virtual machine is. I just wanted to put that in for completeness. So, of course, in addition to the Erlang virtual machine, there are lots of other ones out there, Java and .NET. If you're my age, you might remember the UCSD P-code Pascal virtual machine, which isn't particularly relevant to anything. I just thought I'd mention it and make myself look old. But compared to, other mainstream, current virtual machines that, are in sort of the mainstream, I think the two obvious ones are Java and the .NET CLR. So how is the Erlang virtual machine different? What design decisions drove that?
Well, first of all, I guess when the Erlang virtual machine was developed, none of the other ones existed yet.
This is true.
So that's one of the reasons why you had to build one. It also has a different mindset with concurrency and all that. So you have to have a specialized machine working with having separate concurrent entities running next to each other, the processes, rather than having the sequential way of running code that the CLR or the JVM works. So having a different one there. Yeah. But I guess mostly it's because it didn't exist any other ones. And most of the virtual machines are targeted to the language that they're compiled from. So it makes sense to have a special one.
Although at this point, of course, all three of those virtual machines we mentioned, now we're in many languages each. There are more languages than you can count on the JVM. There are at least a bunch on .NET CLR, and there are a bunch on the Erlang Beam. Robert over there, I think, wrote about half of them.
And for some reason, it's easier to implement languages on top of virtual machines than to implement virtual machines themselves. So there tend to be a lot of languages on a virtual machine.
That makes sense. So, all right, Kostas.
Yeah, but I think you have to separate two different things. So there is one, on the one hand, you have the virtual machine design, which is the instruction set that it has and the runtime system that supports this instruction set. And then you have all the engineering work that goes into the implementation of the virtual machine. And I think there are a lot of languages these days that target, say, the JVM, not because the JVM is the most appropriate virtual machine for that language, but because there is a tremendous engineering effort that has happened over the years. So they try to take advantage of that work, as opposed to trying to take advantage of a virtual machine that is suited to the needs of the particular language.
Right. I mean, the big advantage of the JVM is that there's been a huge amount of money spent on engineering it, and there's a huge amount of experience with like operations people who know how to deploy it. You know, you tell an ops guy, oh, this is a Java thing. They probably know what to do with it.
Yes. So Lucas is absolutely right, of course, that when Erlang started, these two kinds of machines were not around. And even if they weren't mature enough to. But even if we had to do the choice today, engineering issues aside, I mean, like, I don't think that the JVM is a particular good target for a language like Erlang. I mean, most of the work that Erlang does is either related to concurrency or to the compilation of pattern matching. And I don't think that I think that none of these things are particularly well implemented or well suited for the JVM.
Right. I mean, the JVM, in terms of concurrency, basically uses OS threads, which are, for the type of concurrency Erlang is doing, are much too coarse a granularity for most things. You know, we like the fact that an Erlang process takes, what, a kilobyte of memory?
Yeah. But I mean, you could also implement all the stuff that's implemented in C in the current Erlang virtual machine to implement that in Java, with having OS threads migrating jobs in between the different parts, and then getting that. But you still wouldn't get all the way because you have these garbage collection pauses that end up all in different parts, and you also don't get access to the operating system in the same way, so you couldn't optimize certain parts, you don't get the same freedom, and also you're dependent on people in the JVM development team doing stuff, so you're building a virtual machine on a virtual machine, which is kind of, yeah.
Turtles all the way down.
Yeah.
Yeah, I mean, in the level of, it's kind of silly. I've heard somebody implemented a version of the JVM that you can run in JavaScript, and there's a version of JavaScript you can run in the JVM, so you could, in theory, run JavaScript in the JVM, implemented in JavaScript, running, you know, although at a certain level, and I'm pretty sure I went past it there, it just gets silly.
Yeah, there's a version of the Beam virtual machine implemented in JavaScript, so you can run it in your browser.
Oh, there is?
Yeah. So you can do that as well.
And there's one written on the JVM too.
Yeah, and you can run JavaScript in Erlang. So.
Yeah. So, does anybody from the audience have any questions about the virtual machine? You know, what question about the Beam have you always wanted to know? Robert has a microphone. This gentleman right here.
So one thing I've always thought about implementing is, basically I don't like Java that much, so I don't want to program for Android. So why don't we have an Erlang phone? And what would be needed to basically implement everything in Erlang instead on a phone? For instance, processes, or users and ACLs and stuff like that.
I think the guy from Google should
Do you have any idea what work it is to implement an OS for a phone? Actually, there is support of Erlang for Android, I think.
Yeah.
I mean, if you want to try it, you can probably program some Erlang on Android.
Is it viable?
Sorry?
Is it viable to?
I mean, yeah.
Could it, you know, I think it's one of those questions of, could you do it? Sure, but the amount of engineering work for the benefit you'd get, you know, the fact is, I might not want to write half the apps on my phone in Java, and I have an Android phone. But the fact of the matter is, somebody already wrote them. I don't need to write a dialer app from my phone. There is one. I don't need to write this app or that app. It already is there. So, if you were to try to re-engineer the whole thing from scratch in Erlang, would that be theoretically possible? Yeah, I guess so. But again, it would cost you a lot of money. And absent some really good business case to do so, why would you do so?
One of the good things that I find with object orientation is doing window stuff, doing graphic stuff. That's one of the few times that I like, okay, let's do some Java swing stuff. That's when I want to do some graphical stuff. And that's a lot of the things you do on the phone is related to that. So.
I mean, I honestly think not so much on a phone, but like building a desktop app for the Mac or whatever, or Windows, whatever you prefer. If you could do that in Erlang and have just every widget on the screen be a separate Erlang process, that'd be really cool. But in order to build that toolkit, you'd probably have to spend a couple $1 million, get some engineers to spend a couple $1 million. And I don't know about any of you, but I don't have a couple $1 million to spend. And if I did, I'm not sure that's what I'd spend it on. Somebody wrote it, I'd be tempted to use. I might use it, but until that happens, I'm not going to worry about it. Similarly, Basho, yes, they're an Erlang shop, but the full text search in Ryak is Solar, which is written in Java because, well, it already existed. There's some level of, well, if we already have this in Java, is there any particular value in writing it in Erlang beyond we like Erlang? That's a silly reason to spend a few $1 million. All right, anybody else have a question? I see a lack of hands out there. All right, so what's the next thing we should know about the Beam? How big is an Erlang process? I mean, how many bytes of memory does an Erlang process take up these days? Before you do anything, actually, when you just do spawn with, spawn sleep or something.
Could it be 233 words of heap plus the process control block, which might be, I don't know, another 60 words maybe, something like that.
So
about 300 words of memory.
So pretty small. Or Unix process is what, about a meg?
Maybe, I don't know actually, but with the threads, one thread usually has 4Ks of stack, so something like that sounds right.
Yeah. I see you're all tweeting really heavily. Come on, folks, ask some questions. We're trying to be interactive here. This is an experiment. Okay, so we basically, and how many machine instructions does it take roughly to switch from one process to the other? Although I realize it's probably going to be somewhat implementation dependent.
That so depends.
This man.
What?
A stack of yay high. I have no idea.
Yeah.
It's so I mean, the virtual machine does so much more than just scheduling processes.
Right. So what else does it do?
Keeping track of timers, doing delayed kind of work that's in the virtual machine. So, for instance, when you're allocating stuff, you're sending messages back to the original scheduler to say that you need to deallocate this, and it does. I can't remember, but there's about a list of 10, 15 of these different tasks that it does, and then schedules garbage collection jobs for different processes on the different things. So it does a lot of stuff, and checking for I/O is another big thing that it does, like seeing if anything is coming on the socket at the same time. So just switching between the two different processes, if you weren't to disregard that, would basically be copying out of the X registers and then copying of the X registers and updating a pointer to the stack. But I mean, normally you do a lot of other works in between there to do other stuff.
Because I was at a conference in Tel Aviv the other day, and I met with a Node.js fanboy, and I was trying to explain to him the advantage of Erlang, and basically I said, look, the issue that Node.js didn't realize they were supposed to solve is that for what they were trying to do, the concurrency model of a standard Unix OS is broken, and the processes are too large. And so in Erlang, something like Erlang or Haskell, you solve that problem, and you can still have let the scheduler do some of the work, and you don't have to do it yourself. And he was like, but blocking. And
Yeah, blocking is bad.
totally failed to figure out, understand what I was trying to get at.
Yeah, I mean, I wasn't at Eric's talk before, but I mean, most of the stuff when we're talking about long running jobs and these things that we're using the wake up interval flag and so on, that's because of blocking. Blocking is a problem.
Blocking, what level are we blocking at here within the Erlang?
Well, the whole Erlang scheduler is kind of built on the fact that you come around to a steady state eventually,
Right.
so that when you run for a certain amount of time and then you come back to the same entry point all of the time. But if you're for some reason calling some kind of black hole where you don't know how long time it's going to take, you will never return to that. You might not return to that state at the same time, and then you get problems.
So when you say this, when you say that, it's like, I write some code that's, it does so many reductions, then stops, right?
Yeah.
Stops my code and goes runs some other processes, and then comes back to me later.
Yeah, and I mean, as long as you write pure Erlang code, you don't have a problem. It's when you go into the black hole, that's C or whatever you're calling out to, that's when you get the problems.
Right. So when you write a NIF in C, that messes with the scheduler.
Yep.
Now, so what's the best advice for writing NIFs beyond? I mean, simply
Don't.
Don't. So why? I mean, I keep hearing people talk about NIFs. So why would you write it? Why do people write NIFs?
Well,
And that's
no.
So
Well, I mean, you have to call the operating system sometimes, and we haven't made everything into the virtual machine that you may possibly need. So you have this fantastic library that does funky stuff, and you want to call it. So, of course, you need to call other languages.
Right.
You need to do that from any language. So that's one thing, and then performance. Interpret or virtual machine code can't possibly be as fast as real machine code, except if you have compiled it into the real machine code.
So I think people are using NIFs for good reasons and for bad reasons. So the good reasons for using NIFs is if you already have an available library that does exactly what you want, and this library has been debugged over years, and it's well tested and everything, and then you don't want to invent the wheel, and you use this library. This is the good reason to write an if. The bad reason to write an if is because you think, even before you measure, that your application in Erlang will not be efficient, will not scale to the level that you would like to do, and you start writing an if. And most of the cases, you will end up with a program that has worse performance than what you would get if you write the straightforward Erlang code. You compiled it, you measured it, you did any optimization at the algorithmic level first, then you possibly compiled it to native code, and you measured, and only if that thing didn't give you the performance that you really need, then you can start thinking whether it's worthwhile to invest on an if.
But even in the case where your good case, there are other ways to interface to C code. You might know that. You have a talk about it.
Yes.
So going for an if shouldn't be your first option when interfacing to C code.
Yes.
But I mean, as long as the NIF is perfectly written, good, at least,
That's all my C code.
there's no harm in writing NIFs. I mean, if you have long-running jobs, put it on another thread. If you have short-running jobs, be sure to bump reductions and be nice, and don't run forever or more than a millisecond. That's not impossible to do. So I mean, it's not that people. I mean, the easiest way to avoid problems with NIFs is, of course, not to write them. If you really need to, and for the good reasons, be sure to write them in a good way. And then the problem is gone when it comes to NIFs.
I will admit, I can safely claim that I've written no buggy C code in the last 10 years.
No,
Of course, I haven't written any
neither
other C
have
code
I.
either. So what? I haven't written any C code in the last decade, and probably a lot longer than that. So
Bugs in C, it never happens.
Yeah.
Yeah,
But I'm talking about the design.
If you've never seen the talk 50 and 50 by Guy Steele and I forget who the other one was, there was a bit about C, which is not really safe, but we can debug anything. So, sorry, a little bit of silliness there. Now, also people have implemented obviously a lot of other languages on the Beam. What are some of the reasons you might want to do that beyond the obvious one of interacting with Erlang?
Well, our virtual machine
What?
is the virtual machine. The Beam is really good at concurrency, much as we said earlier. I mean, the JVM is good at a lot of things, but not that kind of that like scale of concurrency that Beam can do. And I know of no virtual machine except from Beam that can do that. So if you want an actor language, you probably would like to implement it on top of Beam. I would.
If you're interested in any of those, Robert, when's the LFE meetup?
Okay. Yes, I say, there's an LFE meetup after this. I can't remember exactly which room it is. LFE stands for Lisp Flavored Erlang, right? So it's for us who love parentheses, but we want to run on a real machine. So that's it. Yes. And I can just say yes. Of course, that's why you use the Beam, because you want these features. That's it. Really.
And any other questions from the audience? Person over there on the far side. I can't actually see who you are.
So my question is how much the design of the Erlang virtual machine is influenced by other virtual machines. So does it happen often that they put a new feature into the JVM and the Erlang team says, wow, that's cool, and we add it?
That never happened.
Yeah. There are two problems with that. First of all, you'd have to have a feature in the JVM that somebody will look at and go, wow, that's cool. And that doesn't happen very often. And second of all, from my outsider's point of view, it seems like the Beam team is, and in a very good way, extremely conservative about what they put in. Would you guys say that's a true statement?
Yeah.
Well, it depends on where you're putting the stuff in. There's areas where we can play around a lot, and there's areas where we have to be rock solid and do different parts. But drawing from where we draw inspiration, I can't speak for everybody, but me personally, I don't look that much at the JVM because it's kind of closed source and you can't look at it, actually. But there's a Lua implementation that I at least draw some inspiration from when looking for new strange ideas about how to do stuff. It's like a Lua JIT 2.0 or something like that. It's called. It has some very nice, interesting ideas. But that's like when you're executing, looking for ideas about how to execute sequential code, because there we can draw ideas from different areas. But when you're doing parallel code, it's kind of nobody else usually do the stuff that we do.
And it kind of depends on what you're looking for. If you're looking for JIT, for example, like Lua is really interesting. If
you're saying JIT as in just-in-time compiler, not JIT as in the version control system, just to clarify for people.
If you're looking for a just-in-time compiler, you probably would look at Lua. But if you're looking for something like maps, you might look at like Python. And if you're looking for transactional memory, you would look at Clojure. I mean, you look at languages. Sometimes you look at virtual machines. Sometimes, I mean, the only thing that comes to mind that we took from Java or was inspired by Java is the backtrace, the line numbers in the backtrace.
We like that. I like that feature.
Yeah.
Although, I mean, I can't imagine it Java invented it.
No,
it seems a fairly obvious thing.
It was just that I had some students that had ran Java and then they ran Erlang and they asked me where are the line numbers in the backtrace. And then I went to Björn and said, where are the line numbers?
All right, Robert, gentleman over here.
So before that, I think
You don't need
just
line
for
numbers.
historical reasons, the beam is very heavily influenced by the WAM. So it's sort of started by doing a lot of things that the WAM had. So this X and Y registers, for example, is
By what?
there is a machine, there is an abstract machine called Warren's abstract machine, which is what is used for Prolog implementation.
Okay.
And the whole design of a subset of the instruction set of the beam is very heavily influenced by the WAM. So in that sense, it follows a tradition of so-called register-based virtual machines, which differ from the more commonly used stack-based machines like the JVM. So there have been influences in the past. And as Patrick said, of course, nowadays that the language is evolving by, say, adding, not nowadays, but adding, say, bit streams. There has been a whole lot of changes when these bit streams were added. And these days that maps are added, there have been a lot of changes and influences from implementations of map-type data structures.
Gentleman over there.
So I'd be interested to know the importance of immutability to Beam. Because clearly it's possible to create an actor program where the actors themselves use mutable variables internally. So how important is the fact that Erlang and therefore Beam doesn't provide immutability to its implementation?
Well, for the garbage collector, it's pretty important, for example. That's what you ask for the actual implementation of the virtual machine. If the
Well, I guess the follow-up to that is, what would you lose, hypothetically speaking, if it wasn't immutable at that level?
Well, you had to re-implement the garbage collector, of course, and you could create like circular structures. You could do a lot of unpleasant stuff if you had mutability, and besides a language with mutable.
So, also, I would imagine in Costas, if you had mutability, would it make something like dialyzer much harder to write? No.
No. But
I guess I struggle to believe that it's just the garbage collector. I think there must be more to it than that.
There's also the fact that if you have closure, if you're using a closure and you're sending it to another process, the fact that it's immutable. There's a whole class of bugs that by making things immutable just go away, because there are all sorts of bugs involving sharing of mutable state. If you don't have mutable state, you can't share it, and therefore all those bugs simply can't happen. Sort of like the fact that Erlang automatically does big integers, and you can make integers as big as you want modulo your memory. So, all the bugs that resent integer overflows just aren't there.
Sure, I mean I appreciate the value of immutability at the application level. I guess what I'm interested in is whether or not immutability, the fact that Erlang as an immutable language gives benefits to you, the VM designers, which the VM designers of, for example, the JVM don't have, because they have to support mutable languages.
Yeah.
Well, I mean, under the surface, it's not really immutable all the way as well, because there's some cheating tricks that are done with records and so on, where we can figure out that, okay, so we're destructively updating fields in a record, and there's also the binaries that are being appended to. So there's a bit of immutability going on behind the scenes as well in there. But yeah, I guess just the garbage collection, making it, I mean, having immutability means that we can garbage collect per process much easier. Otherwise, you would have to send these cyclic structures to another process, copy the entire data over there either way, and then in order to do the garbage collection. So yeah, it's
no. So first of all, there are two totally different levels of talking about mutability versus immutability. There is the level of the language, and there is the level of the virtual machine. I think the most important one is the level of the language. There are clear benefits on having a language where you don't have a mutability operator. You can reason about your programs. Then, of course, the fact that you have such a language allows you to take advantage in the implementation of the virtual machine and do some things like, for example, having a faster garbage collector, because you don't have to keep things among, say, generations when you use a generational collector. But I think that's the detail. The most important thing is that you don't have mutability in the language. And as Lukas said just now, in the level of the virtual machine, there are cases where there is mutability happening. It's just that these are not visible to the programmer because you don't have mutability at the language level.
Any other questions? Gentleman in the plaid shirt.
Okay, I have a question about history. I like that. For the JVM, in the beginning, there were ideas about running it in special purpose hardware. So was there ever ideas like that for the Beam?
Yeah, there were.
Has anybody ever done it?
Nah, well, not for the Beam, but for Erlang as such. There has been tries to do a special processor for Erlang. Yeah.
I remember back in the 80s, there were some machines that were specifically designed to run Lisp.
Yeah, like on the same lines, there were ideas that died. Yeah.
There's the Erlang on Zen, which is now called Ling, has been open sourced. Yeah. We did a podcast with them a while back. I'm not entirely clear what the best use case for that is, and I think the ones they presented were kind of silly, but I'm pretty sure there are some cool use cases for it. I'm just not sure what they are yet. So.
But it is Erlang.
What?
It is Erlang on the. It is the Beam on the hardware.
Right, but it's you're basically. The thing is, if you look at the standard Linux or Mac, or his Mac or my Mac or Windows, whatever, you have, and you want to run Erlang on it. And obviously, if you're doing development, you want your editor and stuff that's different. But if in production, you've got Linux, Red Hat or whatever, or Ubuntu, whatever your favorite Linux is. You got Erlang on it, but then you got all this other Unixy stuff that may or may not be of actual benefit to what the application you're trying to run is, So the idea of sort of getting rid of most of that seems to make sense, and there are various efforts to do that, including the Erlang on Zen Ling thing that has been mentioned. But that's a subject for another day. And actually have a couple people I'm trying to get on the podcast in the future who will hopefully talk about various projects in that direction. Robert, how much time do we have left?
I don't know.
I think
It's 6 o'clock.
6. When are we supposed to end?
6 o'clock.
Okay, so
Any more questions?
let's have one last question.
Come on, lay it into them.
Joe, can we tag you for a last comment?
But I've got a question here.
No,
first.
we have.
Oh, we got a question over here.
Yeah, we have
Okay.
a question.
Okay. I'm wondering if you had a chance, the free hands, to do any change, any design decision in the Erlang VM that you could change, what would it be?
Then we would have changed it already. I mean,
I'd port it to run on V8 with Node. Oh, kidding, by the way.
I don't know.
I'm not that
What do you think?
pessimistic. What?
Yeah, no, it's
I think the change I would make, and I'm not sure if this is a VM issue, and I think is the idea that when you're reloading code, you could have more than 2 versions of a module. Now that we have machines with gigabytes of memory, I don't know if that would be how hard that would be to implement.
probably change how integers and floats are sorted.
Yeah. That's it.
Very
The
pressing
things-
need.
Yeah, the things we cannot change because of backwards compatibility. There's a lot of
so many different small corner areas, like how port signaling interacts with process signaling and so on, the nitty-gritty details of those things, and yeah.
So, of course, implementers love doing changes and doing improvements to machines. I mean, and there is not just a single thing that can be improved in Beam. This is true for all abstract machines. Wherever you look at, there will be always millions of things that you have to change. But one particular favorite of mine is something that we have an almost working version and will hopefully appear in an OTP version relatively soon, I hope, is a sharing, preserving, copying implementation.
What does that mean for us non-VM experts?
So whenever messages are sent, whenever there is a term that is being communicated somewhere outside its process, be that sent as a message to another process, or, for example, put in a net stable or something like that, the internal sharing of terms is destroyed. In practice, this means, in practice, you don't notice it that much, but there are situations where you can be exponentially worse. And it's fundamentally wrong, I think, for a language that is based on message passing to have a basic operation be exponential. So I think I definitely believe that this has to change, and we have a working prototype for this that will probably make it into some OTP near you.
Yeah.
I think we need to close up. We think one.
I was going to have a last question.
I
was just wondering why everything wasn't first order. I mean, there's no module to list of functions and list of functions to module, and protocols, for example, are very important, but they're sort of, the protocol isn't itself a first order object in Erlang that you can reason about. Oh.
All right.
Sorry.
I think the takeaway from this.
No, it's your fault, Robert.
This podcast is you can blame Joe and Robert. No, guys, it's General Protection's fault. We should demote him down to Colonel. All right. Thank you, guys. Thank you to my panel. Thank you, guys. Thank you very much, everybody, for coming. I hope you learned something. I hope you found this interesting. Please go press the green button on the thing so that we can do this again at a future conference. I hope we'll do it again next year on a different, not on the Beam, but on some other topic. And if you have a topic that you think we should cover on Mostly Erlang, either live at a conference or just in general, or if you're doing something cool with Erlang and you'd like to come on to the podcast and talk about it, we do it over Skype, usually on Thursdays, but we can be flexible. Come catch me in the conference, or just send me an email or Skype me or something. But our goal is to promote the Erlang ecosystem and the Erlang infrastructure, and that includes LFE, Elixir, Erlog, Joxa, and any other crazy ideas you have for what to do with Erlang. So I really think trying to make the podcast a way to increase the community for everybody. So please help me do that. And if all else, go out and be creative. So thank you very much.